Okay, time for air hockey pucks. It says two identical air hockey pucks of mass 0.17 kilograms and length of 0.50 meters are traveling towards each other in a straight line on an air track. The hockey pucks are square. Just go with it. All right, so it says the initial distance between the centers of the pucks is 0.9 meters, and both blocks are moving at a speed of 0.18 meters per second. Determine the time taken for the blocks to come in contact with one another. Well, we have a distance, in this case, of not 0.900, but 0.850, because we have to get that off there. We have to take into account that these pucks each are going to meet right in the middle here, and we have to take off this amount, which is 0.025 on either side. So if we look at 0.900 and we minus 0.025 minus 0.025, we should get 0.850. So that's how we get our distance as being 0.850. Now there's more than one way to load this dishwasher. We can say that we could take one of these blocks and travel it at 0.18 meters per second across the full length to solve for time, and then divide that time by 2, knowing that this other block is moving at the exact same speed towards it. So we can say, all right, this block, I'm not gonna worry about this block, and I know that they're gonna meet right in the middle, so I can just calculate this entire 0.850 distance and then get a time value for it and divide it by 2. That's one way to do it. Or you can say that each of these is moving towards each other at 0.18 meters every second. So 1 second later, each of these would have gone forward another 0.18 and another 0.18. So they're closing the gap at twice the rate. So you can say that the velocity is 0.36 and then just solve for time. It's up to you how you want to do it. The way that I did it was I took the velocity at 0.18 meters per second, meters calculated for time. Velocity is distance divided by time, and going 0.18 is equal to 0.850 divided by time. So 0.850 is equal to 0.18 t divided by 0.18. And you get 4.7, so that time of 4.7 seconds, and then what I would do is just take that in half, because I took one block going the entire length. So divide by 2, and you get 2.36. And if we want to do this with sig figs, we're going to call it 2.4 seconds. So far, so good. So it says, as a result of the collision, the blocks reverse their direction of motion and travel at the same speed as each other. During the collision, 20% of the kinetic energy of the blocks is given off as thermal energy to its surroundings. State and explain if the collision is elastic or inelastic. So you have to state what the answer is and explain why. So you should have recognized, because there's kinetic energy lost, that the collision is inelastic. So we're going to say inelastic because there is a loss in kinetic energy. So it says, show that the final speeds of the blocks relative to the surface is 0.16 meters per second. This is a great little trick for IB, because what it does is it's basically telling you, oh shoot, am I out of the camera? Almost. Hold on, team. There we go. Okay, so it says, show that the final speed of the blocks relative to the surface is 0.16 meters per second. So what you're actually just doing is confirming what they're already telling you. So you already have an answer to work towards, which is really nice because it'll let you know if you're on the right track. So basically what we're looking at is if the collision were elastic. So in other words, what would be the total kinetic energy in this system if it were elastic? We would say that it's 1/2 mv squared, right? So that value is going to be 1/2 times one of the masses of the blocks, 0.17, times the velocity squared. And I'm not going to hammer that out for you guys. Well, yeah, I will. So we get 0.5 times 0.17 times 0.18 squared. And we get 0.002754 joules. So that's if there was a completely elastic collision, and that would be the total energy in that system, excuse me. So now we know that that's not what's happening. We're losing 20% of the kinetic energy. So what that basically means is that we're taking 80% of this value, right? Because you're losing 20, so you're only getting 80% of this value in the collision. So KE at 80% is going to be 80% of that value, so 0.002754 times 0.8, and that's going to give you 0.002232. So if we just multiply that by 0.80% of that total value, and that's how that number comes up, or that's where I got that value from. So now, if we say that it's only 80% of this energy is remaining, this becomes what we plug into the energy equation. So KE is 1/2 mv squared. And we're going to use this 80% value because it lost 20% of the kinetic energy. So 0.002232 is equal to 1/2 times the mass, 0.17, times v squared. Remember, it's asking us to confirm. So we will be in a good place if we hammer all these calculations out, and once we get them all hammered out, our velocity is equal to 0.16. So let's take a look at half of 0.17. So we're going to take this value here. We're going to divide it by 0.5 times 0.17. And we get 0.02592 is equal to v squared. Take the square root of this bad boy. Second square root, second answer, enter, and bam, we get a velocity of 0.16 meters per second. Done. So now it says the duration of the collision between the blocks is 0.070 seconds. Determine the average force that one block exerts on another. So we're going back to the impulse equation again. F delta T is equal to M delta V. So our force times the time of 0.070 seconds is equal to the mass of one of the blocks, 0.17, times our final velocity minus our initial velocity. Now, here's where things get a little wonky. Our final velocity, if we say, is 0.16, then that means we're looking at this block up here. Can you guys still see that? Yes. Okay, so we're looking at this block up here going in this direction first, because the final velocity is going to be a positive if we designate everything going this way being positive and everything going this way being negative. So if we look at this coming in, this is actually going to be our initial velocity, or if we treat our final velocity as a positive, so 0.16, minus our initial velocity is actually a negative. So negative minus 0.18, because the direction reverses. Tricky, tricky, tricky. So now we can take this value here and we can divide it by 0.070. And we're going to get 0.16 minus a negative 0.18. Times it by 0.17 and divide it by 0.07. And we should get 0.825. And using sig figs, we're going to round that up to 0.83 newtons. So if we did this the opposite way, you would still wind up with the same answer, because if you're getting an initial velocity going in as a positive, you would get, so let's just do it as if we're looking at the other block. So F delta T equals M times VF minus VI. So force times 0.070 seconds, it's going to be equal to 0.17 times our final velocity. So if our final velocity, if we're looking at this block instead, our initial velocity is going to be a positive 0.18. Our final is going to be a negative 0.16. So negative 0.16 minus 0.18 divided by the time. So we divide both sides by 0.70. And now, in this case, we're going to get negative 0.16 minus 0.18. And look at that, you get that same value, but it's just a negative because it's equal and opposite, right? So we're gonna multiply that by 0.17, and you guys can see that this is gonna carry out and still be the same answer, except it's just gonna be a negative value. So in this case, because the question says determining the average force one block exerts on the other, basically that means that it doesn't matter if you leave it as if you choose the positive block or if you choose the negative block, you're going to get the same answer no matter what. So that was one thing that tripped up the air hockey pucks group, was getting this, not forgetting that you have to maintain your positives and your negatives when you're looking at blocks that are switching direction as a result of a change in momentum. So that's that.